In our last section, we learned how to find the missing value c that creates a perfect square. We could use the formula or this method either way. But what's the whole point? The whole point was we want to write something in vertex form. The vertex form, though, so completing the squares all to get vertex form, is a times x minus h squared plus k. That's what vertex form is. And what you'll realize is that this part here is a perfect square. So that's a perfect square. So that's the whole point of why we're trying to get the perfect square. So let's go through some basic ones. I got a couple here that we'll go through. So for our first one, x squared plus 2x minus 3 equals 0. So we're going to be solving this one. So let's create our perfect square. Is this currently a perfect square? Well, let's take b. We'll use the formula method. Or either way, you know, b is 2, so this would have to be 1 and 1. 1 times 1 is 1. So c needs to be 1. But is this currently a 1? No, it's not. So what we're going to do is we're going to add 1 and subtract 1. Because what's 1 minus 1? 1 minus 1 is 0. We're basically adding 0 to this problem. It doesn't change anything, right? If you add 0 to something, we're not changing our function at all. We're changing the form of it. Why would we do that? Well, because this right here is a perfect square. And I'm going to tell you just a quick little shortcut right now. It's always going to factor down to half of this number. I mean, you could go through it. You have the factors right here, actually. It's already been factored out right here if you use this method. It's going to be x plus 1 squared. So it's always half of this number like we talked about earlier. So this is going to factor down to x plus 1 squared minus 4 equals 0. Now notice this is the x plus something squared. So we know that's going to be x plus 1 squared. But it says equals, so we got to move this 4 over. So pay attention to that format whenever you're doing your work. So I'm going to move the 4 over to have x plus 1 squared equals 4. A little bit different format than what you're going to see in the next example. So in this example, we're going to go through the same thing. Oh wait, that's not exactly, maybe it's this one that I wanted to go through. Let me see if we have one with odd numbers. Not yet. This one's kind of a special case because it's already a perfect square. You know, what two numbers add to 14? 7 and 7. And 7 times 7 is 49. So you'll realize this is already a perfect square. It's going to factor down. It'll just factor down to the x plus 7, x plus 7. And so that would be your answer, 7 and 0. So this one's kind of one of those. It's easy because it's already a perfect square. So we don't have to add or subtract anything. So here's what I wanted to do. Because notice this one doesn't equal 0. They're keeping everything on the same side. So we have x squared minus 8x minus 51. And I guess we'll say that f of x equals that. So let's go ahead and go back to that method. Like I said, I kind of like that method because you can already see it factored out. So our b is negative 8. So that means negative 4, because it's half of negative 8, right, is negative 4. Negative 4 minus 4 is negative 8. So that's good. Negative 4 times negative 4 is going to be positive 16. So that's the number we're going to use. It's our magical number. So I'm going to add 16 and take it away. Why would we do that? Because this right here is a perfect square, and it's going to factor down to this right here. X minus 4 squared. Then on the outside, we simplify it. Negative 16 minus 51 is negative 67. So put negative 4 right there and negative 67 right there. And that's it. That's how we complete the square.